Hello and welcome back to the course on machine learning. This is Kirill Eremenko, and in today's tutorial, we're talking about the naive Bayes classifier. This is a very interesting machine learning algorithm, and today we're going to get to know it on a very intuitive level. All right, so here we've got the Bayes theorem, and this is something we talked about in the previous tutorial, so by now we should be quite comfortable with the concept. How are we going to apply it to create a machine learning algorithm? Well, let's have a look. Here we've got a dataset. So it has two features. It has x1 and x2, and there are two categories. Category 1, which is red, and category 2, which is green. But instead of working with these abstract terms, we're going to convert them into something that we can understand a bit better, something that's a bit easier to operate with or to talk about. So we're going to call the y variable, x2 variable salary, and the x1 variable is going to be age. So basically, we're representing observations or people that are part of our dataset in terms of their age and salary. As you can see, we have 30 people here on this chart. And the categories, we're going to replace them with walks, meaning that person walks to work, and green will be drives. That means that person drives to work. And so now we get to our problem, to the machine learning challenge that we're going to be solving. What happens if we add a new observation, a new data point into this set? How do we classify this new data point? So as you can tell, this is a supervised machine learning algorithm because we're classifying something based on previously known classes. And so the question is this person going to be classified as a person who walks to work, or is this person going to be classified as a person who drives to work? And the naive Bayes algorithm is going to help us solve this challenge. All right, so how are we going to approach this? We need a plan of attack. It is going to be quite a complex approach, but at the same time, we're going to break it down into steps and it'll all make sense. It'll be very easy to understand. So our plan of attack. We're going to take the Bayes theorem and we're going to apply it twice. First time, we're going to apply it to find out what is the probability that this person walks given his features. And X over here is the features or represents the features of that data point. So let's go back to the visualization here. So here you can see that this is our new data point. That person has a certain age. So let's say the age of that person maybe is like 25 years old. And then they have a salary. So let's say their salary is $30,000 per year. So those are features of this observation. Right now, we're only working with two variables, just for simplicity's sake, so we can visualize things, age and salary. But in reality, there could be many more features. There could be features on how many, what industry they work in, or how many years of education they have, or how long they've had a driver's license for, and things like that, of how far away they live from work. So there could be lots of variables, but at the same time, right now, we're only going to be dealing with two, age and salary. And regardless of how many variables you have, they will be called, and we're going to call them features. So given the features of X, so given the age of 25 and the salary of $30,000, and we'll talk in more detail about exactly what we mean by features just in a moment. And so therefore, this part represents that person that we're trying to classify. What is the likelihood of a person with those features X? So we know that we're taking somebody for those features that we have in our new data point. What is the likelihood of them walking? And then we've got the right side. So we're going to talk through each one of these as we calculate them. But for now, let's just give them their names going from right to left. So this one over here is called the prior probability. And we're going to calculate that first because it's the easiest to calculate. Next one is the marginal likelihood, and we're going to calculate that second. The third one is likelihood. That's just the names that they have, and we're going to calculate that third. And finally, what we're looking for is called the posterior probability. We're going to calculate that fourth. All right, so that's our plan of attack for step one. This is all still step one, to calculate the probability that somebody walks given those features X that we see in our new data point. Next, we're going to have step two, where we're going to calculate the probability that somebody drives given those features X that we see in our new data point. And again, here we'll have the prior probability, which we'll calculate first, then the marginal likelihood, then the likelihood, and then we'll get to posterior probability. And finally, we're going to compare the probability that somebody walks given features X versus the probability that somebody drives given features X. And then from there, we'll decide which class to put that new data point in. So as you can see, the naive Bayes classifier is a probabilistic type of classifier because we're first calculating the probabilities, and then based on probabilities, we're assigning a class. All right, so are you ready to perform these steps? It's going to be lots of fun. We're going to take it nice and easy, nice and slowly, so that we understand everything. And after this, you're going to be very comfortable with the naive Bayes classifier. Step 1. All right, so here we have our visualization. Let's move it all to the left a little bit so we can make some space. Now we're going to calculate the first probability in our Bayes theorem. We're going to calculate the probability that somebody walks, right? Just the overall probability. And what does that mean? That is the probability that somebody walks without knowing anything about them. So we're just saying we're going to add a new observation to our data set into here, but we don't know their age and we don't know their salary. We're just going to put it somewhere into our data set. What is the probability that this person that we're adding to our database walks to work? Well, it's very easy and straightforward. From here, we don't have much choice. The only thing that we can do is calculate the number of red observations, the number of people that actually walk, and divide by the overall number. So probability that a person walks to work without any other knowledge is the number of walkers, number of people that walk, which is these red dots, divided by the total number of observations, the green dots. So the gray dot isn't participating in these calculations. So here we have probability of somebody walks is 10 red dots divided by 30 dots overall. All right, so that was easy. We've calculated the prior probability. Next, we're calculating the marginal likelihood. And this is where things get interesting. So how do we calculate the marginal likelihood? Let's have a look. Here's our data set again. And the first thing that you're going to do is we're going to select a radius and we're going to draw a circle around our observation like that. Now this radius, you need to select on your own. You need to decide for your algorithm. This is going to be like an input parameter into your algorithm. You can select it less, you can select it more. It's up to you. Now, what does this radius do? Well, what we're going to do is we're going to, first of all, just to make things easier, we're going to remove our dot for now, just so that it's not confusing us. And then we're going to look at all the points that are inside this radius. And what we're saying here is that all of the points inside this circle we're going to deem them to be similar in terms of features to the point that we had. The point that we had, remember, it had an age of, for example, 25 and a salary of $30,000 per year. So now we're going to draw a radius around it. And let's say anybody between the ages of 20 and 30 and in the salaries of $25,000 to $35,000, anybody that falls in that circle, again, it's not a square, it's not just a square, it's a circle. Anybody who falls somewhere in that vicinity is going to be deemed similar to the new data point that we're adding to our data set. So as you can imagine, this radius is actually going to have a big say in the way your algorithm works. Well, let's say we have this radius and this is how it all played out. We have 3 red dots, 1 green dot in there. All right, so now what do we do? How do we calculate the probability of X? And what is the probability of X? Well, the probability of X is the probability of a new point that we add to our data set being similar in features to the point that we actually are adding to our data set. So basically, it's the probability of that new point that we're adding, or like any random point that we add, it's the probability of that any random point to fall into this circle. And P of X is calculated as the number of similar observations. So the number of observations that already we can see in this circle, so 1, 2, 3, 4, divided by the total number of observations, which is 30. So P of X is 4 divided by 30. Once again, just to reiterate, P of X tells us what is the likelihood of any new random variable that we add to this data set falling inside this circle. And it is 4 over 30 because we only have 4. Based on prior knowledge, we can tell that there's 4 here and there's 30 in total, so it's 4 over 30. All right, so that wasn't hard at all as well. We calculated the marginal likelihood. So far we've got this one and we've got this one. Next, we're moving on to the likelihood. And this is probably the most complex one. What is the likelihood that somebody who walks exhibits features X? Well, actually, after we've spoken about the marginal likelihood, calculating the likelihood won't be as complex. So let's have a look. So there's our chart. And now what we're going to do is we're going to draw the same circle again. And once again, we're going to remove the gray point for now. And we're going to color our circle. And so anything that falls inside the circle is deemed to be similar to the point that we're adding. So the question is, what is the probability that a randomly selected data point from our data set will be similar to the data point that we're adding? So basically, what is the likelihood that a randomly selected data point will be from this circle given, this vertical pipe means given that that person walks, that we know that that person walks to work. The other way to think about this is we're only working with people who walk to work. So we're only working with the red dots, which represent people who walk to work. So let's forget about the green dots. Now they're faint, and we're not even talking about them at all. We're only talking about the red dots. So the question is, given that we're only working with the red dots, what is the likelihood that a randomly selected data point from our data set, from the red dots, is somebody who exhibits features similar to the point that we are adding to our data set? So basically, what is the likelihood that a randomly selected red dot falls into this gray area, into this circle? That's what the question we're asking. And that's also very simple. Now that we know how all of this works, it's basically the number of similar observations among those who work. So the number of red dots that actually fall inside this red circle, in this gray circle, that's 3, divided by the total number of walkers. So total number of people who walk to work, and that is 3/10. There we go. So that's our P of the likelihood of somebody exhibiting the feature similar to the data point that we're about to add, given that we're only selecting among the red dots. So that's 3/10, and that was our likelihood. So now if we plug all that in, so there we go, that likelihood is done. So if we plug all of that in, we'll get our posterior probability. So 3/10 times 10/30 and divided by 4/30. So if we calculate that, it'll give us 0.75. 75% is the probability that somebody that we put into the place where we're putting X should be classified as a person who walks to work. That was step 1. It was pretty intense, right? Pretty exciting to calculate this value. Now, the next step is step 2. That's step 1 done. Next step is step 2, to do the same thing for the likelihood that somebody with features X will be classified or should be classified as a person who drives to work. And here I'm going to throw you a challenge. I'm going to challenge you to pause this video or rewind back to find out, to have the image in front of you, and do these calculations yourself, to actually go through the same steps and perform those calculations. If you'd like to see and compare to my calculations, then I'm going to put in another video after this one, so another tutorial after this one in the course, so you can just go to the next tutorial and compare. Otherwise, I'm just going to show you the result now. So the result is 1/20 for likelihood, or let's start from the right. Prior probability is 20/30. Marginal likelihood remains unchanged, 4/30. Likelihood changes to 1/20. So the probability of somebody who exhibits features X being a person who drives to work is 25%. So that was step 2. Now we're going to do step 3. We're going to compare the probability of somebody with features X, the probability of them being a person who walks to work versus the probability of somebody with features X being a person who drives to work. So it's 75% versus 25%, and therefore the first is greater than the second, and therefore it is more likely that that person with features X is going to be a person who walks to work than the person who drives to work. So still a 25% chance that that is a person who drives to work, but percent chance that it is a person who walks to work is greater, 75%. And therefore, we're going to classify this point as a person who walks to work. There we go. That is how the naive Bayes algorithm in machine learning works. I hope you found this tutorial useful. I'm pretty excited and pretty proud of these slides, and hopefully this is a step-by-step and simple explanation of a complex concept. And I look forward to seeing you next time. Until then, enjoy machine learning.